multitask. Still got 3 students haven't key in their attendance.
Miss, I cannot key in the attendance.
Why?
The app cannot open.
Haha. Okay, Amanda, is it?
Yeah, Amanda E.
You try again. Just now mine also got some hiccup. Then after that, I clear the cache. Then got log in again.
Okay, Miss.
So for polynomial, the domain is any real value of x. So I write down. Am I right? Is that my correct? Is that your sign diagram?
Yes. Yes.
Yes. Okay. So I'm going to start asking already. This time now I start from the back. Okay, can Ziqi, is it? Am I right? Yeah, Ziqi, can you tell me so what is the value of when I put x equal to, okay, what is the value of f negative 3?
0.
0. How you know?
Because it's the x-intercept.
Yes. So we know that, correct? When we do a sign diagram, we have to get the x-intercept first, correct? So how to get the x-intercept? We put this function is equal to 0. So we get 2 value of x, 3 value of x. Yeah. So we get x squared equal to 5. So my x equal to root 5 or x equal to negative root 5 and another x is equal to negative 3, correct? Okay. So I just want to ask, how can I get the sign for region A? How I know the sign for region A is positive? Okay. Xingren, Tang Xingren.
At the calculator, you use you find the graph and then you calculate and then you put x equal to 3 and then you will get a positive value.
So that means, do you need to draw the graph?
No, yeah. If you
I
want
don't
to.
draw the graph, can if you want to. So do I need to draw the graph here?
No.
No. So what I need to do is, if I want to know the sign, okay, if I don't want to substitute in, I want to use my GC to help me. So how to use GC to get the sign? For each region, okay, what I need to do is first, I need to key in, correct? Key into Y1. Yeah. You key in the function. I keep repeating this to make sure you get the right way. Then after I key in already, what should I do? Okay. Tang Xinqi. Xingren and Xinqi, you are twins, is it? Xinqi.
Yes.
Yes. Where are you all from? Sabah. Sarawak.
Kedah, Kedah.
Kedah. Okay. Okay. You tell me, after I key in already, what should I do?
Alpha trace.
Can I straight away alpha trace?
Press graph first.
Or do I need to press graph first? If my cursor is in the function key here, if I want to come out, so what should I do?
Second mode.
Yes, I have to do second mode first. So always remember this. If not, you are still inside there. Understand? You have to push second mode. Then after that, you only put alpha.
Trace.
You don't have to put the graph. You put alpha trace. Then you get your, select your Y1, right? Then you try with different region. Then you get the sign. Okay, so now, if the sign is positive, that means for x greater than square root 2, can someone interpret for me what is the value of greater than square root 5? So what is the value of fx? Is it greater than 0 or less than 0? Xi Hian.
Yes.
So if for x greater
yeah.
than square root 5, fx is greater than or less than 0. Fill in the blank. Which symbol are
Greater
you
than
going?
0.
Greater than or equal to 0, correct? Because it is positive. So now, if we go back to the question, the requirement of the question, what does the question want? This is my fx. What does the question want? The question want less than 0, correct? So what is the value of range of values of x? Wen Yik, Chong, Chong Wen Yik, Chong Wen Qing. You are also twins, are you all?
Yes.
Okay, so there are a lot of twins. I've been teaching a lot of twins nowadays. Okay, okay. Yeah, Chong Wen Yik first. Wen Yik.
Can you repeat the question again?
Okay, can you answer this question based on this? Can you answer this question based on this side diagram? I ask you to find the range of value of x such that fx is less than 0. So where is the range of value of x?
X smaller and equal to -3.
Smaller than or equal to -3 or where is another
greater than square root 5.
greater than or equal to negative square root 5, but less than or equal to root 5. Am I right?
Yes.
The negative region. So you see, that is how we use side diagram to help us to solve the inequality, or let us have a picture of how the graph look like. Yeah. Okay. So I believe everyone, you are familiar with that. So today I'm going to move on to another type of function. I told you already, whenever you talk about polynomial, correct? Okay, whenever you talk about polynomial, Okay, your domain, unless it's given by a question. If not, you just write like that. Am I right? Right? This is for polynomial only. Then for other function, will it be the same? Let's see. So today I want to give you another type of function. Shall we? Okay, so I think you have seen this kind of function before. Okay, for example, I give you fx. Not good to use rate. Fx equal to x minus 4 divided by x squared minus x minus 6. When you learn function, you got this, correct? So this type of function is, we call it rational function. That means a function is a quotient of two algebraic expression. So whenever you have a rational function, what you need to do is, it's very important to know one very true fact. The denominator here cannot be equal to 0. So this will determine your domain. So this is very important. So whenever you see a rational function, first thing you do, yeah, I want you to draw the sign diagram. You shouldn't draw the sign diagram. You should, first thing you do is to determine the domain. So how do you determine the domain? Straight away, say the bottom cannot be 0. Because when the bottom is 0, it is undefined. That means there is no image, so it cannot be a function. Are you clear? Okay. So now you can use either your scientific calculator or your graphic calculator, or you can factorize it by yourself. Since this can be factorized easily, so I will say x cannot be equal to 3 and x cannot be equal to -2. So therefore, the domain, so this is the first thing when you talk about rational function. Okay. Hello? Can or not? Then if I want to draw the sign diagram, then second step, then only I draw a line. This represents my x-axis, correct? So cannot, on a number line, we will put dotted line. So whenever you see dotted line on a sign diagram, it means x cannot be -2, x cannot be 3. When you see dotted line, means not part of the domain. Are you clear? Okay, then what should I do for the second step? Third step now. Can someone tell me, if I want to draw a sign diagram, what is the third step? That means the second step of our previous sign diagram. Okay. Wen Cheng.
Substitute the number in
Can
the
substitute.
function.
Wen Cheng, you can substitute. You want to draw sign diagram, correct?
Yeah.
What is the second step? What are all that I circle?
X-intercept.
Have you find x-intercept for this function?
Okay.
So you have to. So you cannot jump the step. The step have to follow. Rational, you add one more step. You see or not? Okay, so the third step, you have to find the x-intercept. Okay. Wen Cheng, can you tell me what is the x-intercept? The rest you better follow. If I feel like it, I can call any one of you. So x-intercept, that means fx equal to 0, correct? Yeah, Wen Cheng, what is the answer? So you cross multiply. 0 multiplied by anything is 0, correct? So Wen Cheng, what is the x-intercept?
4.
4. Okay, so now I have my sign diagram for my fx. I have prepared it. So then I determine the sign. So they are divided into 4 regions, correct? So take out your graphic calculator and determine the sign. So do you know how to type fraction into the graphic calculator? When you are in your Y1, correct? Before you start to type, what you can do is you go alpha F1 for fraction. You go alpha Y button. Okay, then you will see this one. This type of sign come out. Right? N over D. Sorry, it's N over D. So you want it to be in this form. So you select this form. Numerator, denominator, okay? You choose number 1. Then under your Y1, it will come out like that. A box on top, a box below. Then you can start to type in. Okay? I hope everyone is typing in. Are you ready? Can I call for the sign for different region? Are you ready? If you are not ready, better tell me not ready. When I call, means I want the answer already. Okay, so I can call. Okay, Shawin. Region A, what is it? Shawin,
Yeah,
region A,
positive.
positive. How you get positive?
I use the x value as 5.
Or you sub in, you use alpha trace F1, then you key in 5. Then you got, what is the value? When x equal to 5, what is a y?
1/14.
1/14. Okay, so positive. Okay, good. Can you tell me what is the sign for region B?
Negative.
Negative. Okay, can you tell me where is the location of the graph for x between 3 and 4?
Below the x-intercept. Below the
X-axis.
x-axis.
Okay, thank you. Okay, so I'm going to call someone to make sure every one of us know what are we doing, okay? Okay. Shafiq.
Yes, miss.
Yeah. Can you tell me what is the sign for region C?
Positive.
Positive. Then for region D?
Region D, negative.
Negative. So look, so now everyone, are you okay? Okay, no response means okay,
Yes.
So
yes.
now, yeah. Okay, so now I want to tell you something. From the sign diagram here, if I have a value of x that cannot be taken, the graph, when I draw the graph, I will have two vertical lines whereby the graph will not cut through these two vertical lines. So this one, we call it the vertical. X, vertical line, the equation is x equal to something, correct? X equal to -2 and x equal to 3 are the vertical asymptote. For the curve fx. Okay, which means that the curve fx will break into one piece here, another piece here. 3 pieces. They are not joined, they are not continuous. Are you clear? They break off 3 pieces of graph. Are you okay? So that is called the vertical asymptote. So now, how to get the vertical asymptote of a function? You look at the domain. Polynomial got vertical asymptote or not? Polynomial don't have vertical asymptote. Only rational function here got vertical asymptote. Later we will study other function also got vertical asymptote. So new term. Have you heard of this before?
No.
No. So vertical asymptote are the x value that the function is not part of the domain. Is a specific value of x which is not part of the domain. That is called the vertical asymptote. Can or not? Hello?
Yes.
So now with this sign diagram, I'm going to redraw this sign diagram on the other page. So we have this sign diagram. Okay, I write down the function first for easy reference. So I have my fx, which is x minus 4 over x squared minus x minus 3. And the sign diagram for fx, we go in this way. 4, 3, -2, okay, plus, minus, plus, minus. So when I put it as a graph, see, that's how I do. So I will mark down the vertical asymptote, another vertical asymptote, and my graph will pass through x equal to 4. Right? This part of the graph is above, this part is below, this part is above, this part is below, this part is also below, right? So I know. So now, I'm going to ask you to use your graphic calculator to sketch the graph. Okay, so now, there are two ways to sketch the graph. So you can fix your own window. So can someone suggest to me, okay, if I got the function already, correct? So my window, what should I set? If I go to window, what value should I set for x minimum and x maximum? So that I can see roughly what happened here. Yep. Okay, I call So be fair. Okay, Serene. Serini or Serene? How should I pronounce your name?
Serene.
Serena. Okay, Serene. What is your x
For the
minimum?
x minimum,
What do you want to choose?
-3.
-3. Okay, we choose -3 as you say. X maximum?
2.
2.
Yes.
If 2, then I cannot see this part already. So what do you want to give to me? If 2, I only can see until here. Then I cannot see my another vertical asymptote already. So what is your x maximum you want to put?
-5.
-5 is here, young lady. How can your maximum is lower than your minimum? My x-intercept is 4. Yeah, Sherry?
Also 5.
Yeah, 5. 6 also can. Huh? Okay, we take your word 5. You see or not? So you with the side diagram, you yourself can choose the range of x that you want. Okay, after that, what to do? Okay, Sharon, since you have on your mic, can you tell me after this what to do? Next. What button to press? Do you have a calculator with you?
Zoom.
You go to Zoom?
Yes.
Yes, good. Got calculator, that is different. Okay, so which one you select?
0.
What is 0?
Zoom fit.
Yeah, zoom fit. Then the graph come out. Right? Do you see the graph break into 3 pieces? This part go like that. Am I right? And this part, how we go? Uh-oh. 3. You think Miss Do have ticked something very wrongly? This part should be above. Yeah, I'm wrong. I know already. Saya sudah salah. I know. This part go like that. It should be all above, correct? It look like there is a turning point here. Am I right? And this part go like this. Am I right?
Yes.
Okay. Can you use your GC and find the coordinates of the turning point A? Pastor, I give you time. We call it local minimum. Do you understand now what you mean by local minimum? Because for this function, correct, in this location, correct, within this location, correct? Sorry. within this location, it is the lowest, but others have some value which is lower than that. So that's why we use the word local. Be very careful. A is a local minimum. A, the local minimum. Okay, so what is the coordinate? Can you please calculate? You know how to calculate or not? Okay, if you are ready, can I call for the answer? Sebastian?
Wait, I haven't calculated.
You know how to calculate or not, by the way, Sebastian? I'm not trying to be sarcastic. I'm just asking you.
Is it you go second and then you go
Second what?
second
Huh?
one sec, sorry, my second F4.
Who is beside you?
No one's beside me.
Then someone is laughing.
It's not me. What?
Okay,
Oh,
second trace.
yeah.
Up there is calculate, correct? Okay, then you
yeah.
choose which one?
The minimum.
Yeah, number one, number three. Number three.
Yeah.
Yeah, okay. Correct. Left bound, right bound, correct?
Yeah.
Okay, yeah. Get it? Done? Can I have the answer?
X equals to 1, y equal 1. I think my function is wrong. Wait.
Your function is wrong.
I copy it wrong, I think.
How can you copy wrong with the function have been there for so long?
Give me 1 second.
Give you 1
It's not
second.
x minus 3, it's x minus 6.
Oh man.
Oh, x minus 6. Oh, sorry. But never mind what. You key in the function right from the very beginning. Am I right?
No. I had it at -6 just now, and then I changed it to -3.
-3. Very clever. You didn't say I'm wrong.
Oh, I thought I mislooked.
I told you already what I can be wrong, okay? Okay, -6. So if you see Mr. write any number wrongly, please remind me, okay? Okay, Sebastian, faster.
I got x equal 1, y equal 1/2.
X equal 1, y equal
1/2.
1/2. Correct or not, class?
Yes.
Yes, correct. So this is you can get the local minimum. Okay. So now, do you think there is another turning point here? Do you think there is another turning point here? Okay, by the way, there is another turning point someplace somewhere here. The graph go like that. So if I want to have a nice picture of this, okay, I want to study this part only. So what should I do? Okay, what should I do? I should go to the window. Yeah, you can go to the window. Okay, what you do to the window is your X minimum. Okay, you just want to make sure it is a bit less than 4. Okay, what are you going to choose? Okay, if I say a bit less than 4, okay, Sebastian done. Suraya? Suranya, is it?
Saranya.
Suranya. Okay, so what should I put as my X minimum?
3.5.
Okay, you can put as 3.5, good. Then your X maximum, give me a value.
6.
6, you may not be able to see.
Can we remain it as 5?
No, if you remain at 5, you can't see because I say somewhere there got a turning point. But just now we plot, we didn't see a look like got turning point, correct?
Yeah.
So I make my X maximum much bigger.
So
Just be
around
brave.
8 or 9.
8 or 9, why don't you put 10? Okay, we put 10, okay?
Okay.
After you put 10, then after that, you go to zoom fit. You go to zoom and you make a zoom fit and see. 0, you select 0, zoom fit and see. Okay, so it gives you the part that I circled. It magnified that part. It magnified that part. Do you get it?
Yeah.
So how is it look like after it's magnified? 3.5. I also do so that I can give you. No error. Okay, then I put 10. Then I make a zoom fit. So after you make a zoom fit, yeah, you can see like it going down. Am I right? So you see a graph. You can't see the x-axis. So the graph go past through 4, then it go like that. Am I right? And here is your 4. You try to find the local maximum here. Please, everyone do your work. Find the local maximum. Second trace, maximum. Left bound, try to get it below. Then change to right bound. Just press the cursor until you look like it's going down. Then press enter, then guess. Okay, can someone give me the answer? I'm done. I did it already. So that's why I can. Okay. Send here.
Yes, miss.
Can I know the value?
Is it x equals to 6.5?
Okay, 6.449. I got 6.449. You got 6.5.
Yeah.
I got 6.449. Do you all get 6.449?
Yes.
So something wrong with yours. 6.45. Okay. So what is your y?
I got 10 over 119.
10 over 119.
Yeah.
They give you in fraction. Better still.
Yes.
They give you in fraction, cannot be. When you use your graph give you in fraction. Are you sure? Did you do second trace?
Yes.
Is your left bound here? And your right bound, your cursor is somewhere here. Because the turning point is not obvious, you make sure it must at the go down part. Hello?
Yes, miss. I'm not sure because is it 0.084?
Hold on.
Okay.
So when you have your curve like that, the curve, okay, the curve go like that, right? It is the turning point is not obvious. So you make sure the left bound is here and the right bound is here.
Okay.
So your left bound and right bound must be like okay, I show you the picture. I give you the picture. I have it. So this is very important, especially when you have a situation whereby okay, that is how my left bound and right bound. So I forward to group 2. Okay, can you see, class? Okay, so then after that you press enter, then it gets. So I got 6.45 and here is 0.084. So there's another turning point here. So every time if you want to study about all this, so what you can do is you want to see what happened to the other part, you magnify it. Yeah, why I know that is because after I'm going to show you something, another thing. Okay, are you okay? So you see our graphic calculator cannot, the graph that they sketch cannot give us a very clear picture. So if you want to have a clear view of certain part of the graph, you go zoom in the part by adjusting the window. Are you okay? Yeah. Can I move on to the last part?
Can.
Can I? Okay. So now I have this function. If I write wrongly, please let me know. Correct? This time correct? Okay. So now I want to know. Do you see when this is my x? When x tends toward infinity, this side, what happened to my function? And when x tends toward negative infinity, what happened to the function? Okay, what happened to the value? I want to study the feature. So I will write when x approaches infinity. So my function fx is made up of 2 parts. So I study part by part first. So what will happen to x minus 4? It will tend to what? Hello? Can someone give me some idea? You will tend toward what? Okay, where am I? Okay. Raisa, Zikri.
Yes.
You will tend toward what? This expression. If my x tends toward infinity, what will happen to the value of x minus 4?
Will it be? I don't know if it's going to be greater or not.
It doesn't matter whether greater or not. If I take a very, very, very big value, minus 4, the result will be very, very big or small? Hello?
I think it will be small.
Huh?
I'm not too sure.
500,000 minus 4. Big or small?
Big. Very big.
So you tell me x minus 4 will tend toward what?
Greater.
It's not a matter of greater. Refer to this. Infinity, that means it's telling you very, very big number. A very, very big number minus 4. Will the result be very, very big?
Yes.
Yes. So we write down there infinity. You get me?
Yep.
So another part of the equation, that is x squared minus x minus 6. Will it tend toward what? Infinity or 0? Okay, let's see. Rachel, he.
Yes, Miss.
Yeah, this expression, if my x is infinity, so you imagine infinity square minus infinity minus 6 will tends toward what? Will be what?
Zero.
Huh? How to be 0? You tell me. I ask you, infinity square and infinity. Do you know infinity square is much, much bigger than infinity?
Yes.
So?
Infinity.
Yeah, infinity. Infinity, Okay, now. So these are all imagination, okay? In university, I have a subject. Every day, every lesson, we talk about this. Okay, so now, this is the first time you are introduced to it. So now, first one, second infinity. If you compare the first infinity and second infinity, both are, we write infinity. Which infinity is bigger? So I have to ask question like, which infinity is bigger? Chocolate.
The second one.
Second one, because of the square, correct? So the second infinity is much, much bigger than the first infinity. All these are something that is you must have it in mind. Do you get me? This is the hardest topic to teach. I'm telling you. All this is in your mind, okay? In your mind, Okay, so now my fx is x minus 4 divided by x squared minus x minus 6. So it will tend toward what? My fx is big. Divide by very, very, very big. So it will tend toward what? Huh? Hello? Shani? Xinyi? Neo Xinyi?
Yes, Miss.
Yeah. So what will happen to my fx when x tends toward infinity?
Uh,
I have 1 ringgit. I give to all Malaysian. How much you get?
1 ringgit gives to all Malaysian. 1 ringgit only.
33 million. So?
Or 43 million.
33 million. So you think? So the fx will tend toward what?
Same.
You just see, you just do like that. You just do like that. This is called very, very big. So it become very, very, very small. So number very, very small will be?
0.
And only 0.1. Approaches what?
Oh, 0.
0. So this one, correct? So you see, if I go back to the graph, I let you have the, okay, look. This part of the graph is, you see, it approaches 0. See or not? This is the x-axis. X-axis means y equal to 0. X-axis, the equation is y equal to 0, okay? It won't be 0. It won't touch 0. But it will go very near 0. So this horizontal line. So this one, so we say, so you look at the graph here. The rest is more than 0 for this part. Uh-oh, gone. How? Okay, It go like that. Okay, everything is above the x-axis is positive. So when we write here, that means for that region, it is the lowest possible. All right? It is the lower limit. So we say from above. That means the rest of the value of y is more than this value. So we say y equal to 0 is the horizontal asymptote. So today you take away two things. That is, the first one, vertical asymptote. Only happen for rational function, okay? How to get the vertical asymptote? Is controlled by the domain. Remember that. How to get the horizontal asymptote? We study what happened to the function when x approaches infinity. Or another direction, when x approaches negative infinity. So my x minus 4 will approach negative infinity also. But my x squared minus x minus 6 will approach infinity. The reason is because infinity negative infinity squared is equal to infinity squared. Correct? So infinity squared minus negative infinity minus 6, it will approach infinity. So therefore, my fx, which is x minus 4 divided by x squared minus x minus 6, will approach same story here, 0. But for this case, it is from below, because the rest of the value is negative. So this is your upper limit. For this location. That's why if I go to the graph, it will be like that. You see or not? From below. This is below. Below 0. The graph is below y equal to 0. So it approach from here. Are you okay? So please watch the video through and through again until this thing sink into your mind. Vertical asymptote, domain. Horizontal asymptote, let your imaginary run wild. This is new thing that you learn. You better go through it over and over and over again until you get all the steps right. I teach you how to imagine it. Yeah? I tell you, we all, when we are in school, we have to imagine by ourselves. Okay, class? A lot of new things to take away today. All right? Okay. Because this is going to be very helpful when we come to chapter 3. I'm telling you. Okay? Thank you, class.
Thank you, Miss.
Thank you, Miss.
Thank you, Miss.
Thank you for being very
Thank you,
responsible.
Miss.
Yeah.